So you got a good idea now what this report is all about. So next up is adaptation technologies for water pollution. So we did too little water, too much water, and now water pollution. Adaptation response starting with limiting nutrient leakage. Water pollution is obviously coming from saltwater intrusion, nutrient leakage, and so on. Sediment loading can also be there just from erosion, etc. Technologies, riparian buffers such as wetlands and buffer strips, strips of vegetation along the banks of waterways like lakes, rivers, streams, etc. that protect the water from potential pollutants from the surrounding land area, such as those from agricultural land and activities. Oftentimes you have natural buffers like subaquatic vegetation, mangroves, etc., which typically have been destroyed or reduced in coverage, perturbed, damaged, whatever you can say. There are many efforts to restore them, but this is about similarly nature-based solutions or ecosystem-based solutions as we call them, or even we call it as ecosystem-based adaptation, which is about using vegetation to filter the water naturally before being released into the water body. Protected areas and land use limitations. So land use limitations and establishment of environmentally protected areas are legislative approaches to help meet water quality objectives and reduce waterway pollution due to nutrient leakage, for example, nitrogen and phosphorus stemming from fertilizer use. There are many details. When you perturb the nitrogen to phosphorus ratio in coastal waters, the ecosystems respond to that. The size ratio, size classes of phytoplankton change, which then cascades into zooplankton, fish, and so on. So you also obviously have things like eutrophication, where you have heavy nutrient load creating blooms of phytoplankton, which cannot be grazed down by zooplankton fast enough, so they sink and then respired by aerobic microbes, creating hypoxia, anoxia, and so on. And often you have, of course, that leads to fish kill, etc., but you also have harmful algal blooms responding to eutrophication, causing all sorts of health issues for humans as well as for fish and so on, right? Change in agricultural practices limiting fertilizer application and sediment control. So changes in land use practices can be implemented to reduce this leakage, particularly nitrogen and phosphorus, and the resulting nutrient pollution of waterways. So we have discussed this elsewhere as well. Again, these come under ecosystem-based. When we say nature-based climate solutions, we are often aiming at reducing warming impacts, acidification. Here we are aiming at water pollution, which is not always directly related to greenhouse gas and warming, but human activities nonetheless in terms of runoffs and nutrient loadings. Okay, so we looked at limiting saltwater intrusion, and we will look at it again in the next table. Mitigating pollution at source, so source water protection and water safety plans. Excuse me, I'm getting a phone call here which got cut off, so let me continue. Am I recording? Yes, I am. So let me keep going. Source water protection entails management and policy measures that restrict overuse and pollution of water at its source, and may include regulations such as water allocation quotas, water quality compliance regulations, compensation schemes, for example, payments to industrial and agricultural users to reduce the use of pollutants or extraction volumes, payments for ecosystem service schemes, or conservation measures in the upstream watershed. So you want to have top-down legislative approaches, as well as market forces and sometimes bottom-up demand from people who live around the water bodies, wanting action from the government or from agricultural farmers and industries and so on. Water safety plans, a risk management tool to ensure a safe drinking water supply for human consumption. Effective safety plans require a holistic approach to water management, where all possible threats to drinking water quality in the supply chain from catchment, supplier to consumer are assessed, and intervention to control contamination risks are enacted. Of course, again here, nexus approach is required. Agriculture, water, energy, transportation, Flood-proofing for water quality is the next adaptation response for water quality. Improved stormwater management, we look at elsewhere. Flood-proof wells, specialized construction design and planning procedures to protect wells against the risks of flooding and consequent water contamination. More ideas there. Flood-proof sanitary latrines. Improved construction design and planning of latrines minimizes water contamination and health risks. E. coli tends to be very high in many coastal waters, so these are very useful to reduce such loads. Next up on adaptation response, improved water treatment capacity. Advanced domestic wastewater, so technologies start with advanced domestic wastewater treatment tanks, constructed wetlands for water treatment. So here you have advanced domestic wastewater treatment tanks used to remove solids, pathogens, and other impurities to meet water quality requirements, so regulations, compliance, enforcement. Constructed wetlands make use of natural purification processes of vegetation, soils, and microbes to remove contaminants from discharge. Again, ecosystem-based, nature-based kind of approach for adaptation. Improved efficiency of centralized water treatment systems. Improved efficiency, so that's moving towards improving efficiency of centralized wastewater treatment plants, including technologies and procedures that treat larger capacities of water, requiring less energy and chemical inputs while improving its quality. So goes more towards real technology in terms of machines and treatment plants. Improved point of use treatment, so treating water at the point of use, such as the household, in places where centralized water treatment systems are not efficient or present at all. Low cost and effective point of use treatment options include physical filtration using cloth, ceramics, sand, or specialized filters depending on the size. In India, it's very common for people to have a filtration system because tap water is generally not trusted by waters as good enough for or potable enough and so on, which is good because tropical countries, warm temperatures tend to have lots of pathogen loads, microbe loads. Okay. Chlorination or disinfectant powders, a chlorine solution or disinfectant added to water, killing most of bacteria and viruses, but that leaves a smell that people don't like. Solar disinfection, so water bottled in clear plastic and placed under direct sunlight, ultraviolet rays, and heat kill pathogens in still water, and of course boiling water. Heat inactivates dangerous bacteria and viruses. So this is very common in poorer countries where fancier sanitation systems, piped in water supplies and so on are not very reliable and so on. So people are used to dealing with their own water quality issues by using these approaches of filtration and boiling, etc. Okay, so we'll come back and look at more on sea level rise and other issues that we talked about in the beginning. This is a bit shorter than the others, but that's just okay. All right, see you in the next podcast.